Hello students, this is the recording for slides 8, 9, and 10 of the Unit 2 project for chemistry. So slide number 8, we're taking a look at the properties of your chosen element. Please do not use Google, you should use ptable.com. So I'll go ahead and click on this link. You'll see that the option to open that link pops up and you will see ptable.com in a new slide. So the question is, what is the state of matter, solid, liquid, or gas at room temperature of the element that you chose? Remember, you could only choose one of these 18 elements that are boxed in these bright red boxes. So taking a look here again at slide 8, in order to find the state of matter at room temperature, all you need to go ahead and do is click on your element. So I'm going to go ahead and use silver. Again, you cannot use silver because silver is not an option from slide number 2. So please do not use silver. This is only an example. But taking a look at silver right here, I can put over here underneath the information here that I want to know what its state is at 20 degrees Celsius. So right here, just go ahead and click that and type in 20 degrees Celsius and click out of it, and you will see what state it is in. And it tells you that it is in the solid state. All right, so I would go ahead and write solid. Again, this is just an example. Do not copy. Okay, for silver. Okay. All right, so that's how you find whether or not what its state is again, just click over here and enter the temperature. Make sure you click out of it so that you have an accurate reading. Then it says, what is the color at room temperature? Color is just based on looking at a picture of it. So in this case, you can go ahead and click on the Wikipedia write-up right here, and you can see what color it is. So for mine, obviously, it's silver. Or I could say gray, for example. And again, this is my example. Do not copy because yours will be different because you are not allowed to use silver. Okay, so that's my example right there. If your compound has many different colors at room temperature, you can note that in here, right? So for example, phosphorus has multiple colors at room temperature. Then it says, is it good at conducting electricity? All right, so for this one, we're going to go ahead and jump back to our information here. And you can see here that if you scroll down, you can see conductivity. There's both thermal, which is heat conductivity, as well as electrical. So what I'm going to go ahead and do is I'm going to actually click on that bar right there, and I'm going to change it from thermal to electric. And you can actually see it's kind of its conductivity. So what you can see here is the number at the bottom shows you the conductivity. So taking a look here, you can see silver, its number at the bottom now is 62. All right, and that is also showing you that it's really dark purple, which is a really high electrical conductivity. So for mine, I would put high electrical conductivity. And again, this is my example for silver. Do not copy because you're not allowed to use silver. All right, then I'm going to go ahead and take a look at its heat conductivity, whether or not it can carry heat well. So same thing, make sure you're clicked on the heat on the conductivity bar and change it to thermal. Thermal is another word for heat. And taking a look here, you can see the bottom number now says 430. And you can also see, again, it's dark purple, which shows me that this is a really high maximum amount of conductivity, right? If you're a lighter color, that's going to be less. You can also see like fluorine, for example, has 0.0277. Helium is 0.1513. Those are all really low conductivities, okay? But for silver, I can see 430. So again, this is going to be high. And example for silver, do not copy. Okay, is it lustrous or dull? Again, this comes from the picture of it. So one more time, you're going to go ahead and take a look at its picture. So come back up to, click on silver. Come back up to its write-up and look at its picture, and you should be able to see if it is shiny, which means lustrous, or dull, which means not shiny. So in this case, my example would be lustrous. Example for silver. For silver, it is shiny. Do not copy. Okay, again, yours might be lustrous, but don't copy that it's lustrous if you have something that's not a metal, for example. Again, most metals will be lustrous, most non-metals will not be, and most metalloids will be in between. Is it malleable, ductile, or brittle? So taking a look here, we're going to go ahead and take a look at its malleability. And we can find this by taking a look at the Wikipedia page. Again, if it's a metal, it's most likely malleable. If it's a non-metal, it's most likely non-malleable. And if it is or it's most likely brittle. And if it is a metalloid, it could be either malleable or brittle, although usually more brittle. All right, the way that you can find this is you can actually just read the article. If you want to, you can press Control F to find, and then you can actually type in the word malleable and you'll see it pop up here. If for some reason you can't find this one in the Wikipedia page, this is the one instance in which you can use Google. So for this one, you can use Google and just Google, is it malleable? All right, so for this one, you can say, is my element malleable, is it brittle, etc., etc. So this is the one time I would actually accept using Google if it's not in the Wikipedia article. All right, so in this case, I would put it is malleable and ductile. All right, malleable meaning that it is malleable, ductile meaning that you can bend it, stretch it, etc., which is what you can do to metals, especially once metals are heated. Okay, all right, so that is going to be the slide number 8. Let's go ahead and take a look at slide number 9. Slide number 9 says, from slide number 5, how many protons does your element have? So again, take a look at, oh, sorry, this should say from slide number 3, from slide number 3. I apologize. So this should say slide number 3. Okay, so from slide number 3, you should know, oh no, sorry, slide number 6, slide number 6. I apologize. Okay, sorry. From this should say, instead of slide number 5, it should say from slide number 6. Slide number 5 is the picture. Anyways, from slide number 6, how many protons does your element have? Again, that's based on atomic number, which is identical to the number of protons. So taking a look here for my example here, I'm going to go ahead and use a different example. Let me go ahead and use, let's see here. No, actually I'll still use silver. So if you take a look at silver, again, its atomic number at the top is 47. So I would have 47 protons for my example here. Please do not copy that example. And then take a look here, how many total electrons does your element have when overall neutral? So remember that when you have a neutral atom, your protons and electrons have to be identical to each other because that way they balance off, right? If you have 47 positive protons, 47 negative electrons, that would cancel out to 0, making a neutral atom. So this should actually be the same, right? Again, this is my example, and this should be the same. Okay. All right, so then taking a look here, based on how many electrons your atom wants to gain or lose from slide 7, how many total electrons would a stable ion of your element have? So taking a look back at slide number 7, right, we talked about how many will it gain or lose. All right, so for silver, let's say that silver has 1 valence electron, so let's say that it wants to lose that 1 valence electron. Remember, silver is kind of a weird one because it's a transition metal, but for our purposes, let's just say that it loses 1 electron. All right, so I'm going to say it loses 1 electron, and so I need to subtract 1 from the answer above. So I need to subtract 1 from 47. So if it loses, again, subtract 1, and so my answer would be 46, and that is my example, in order to form a stable ion. Okay, so this is my example. Do not copy my example. Okay, now if you decided on slide number 7 that your atom gains electrons, then you should add to the electrons from above. So for example, if I gained 1, then I would add 1 to 47, and that would become 48 electrons. All right, so again, make sure that you pay attention to this part right here. I'll go ahead and just box this. Make sure that you pay attention to this part right here, okay? Oops, that's not what I wanted. All right, here we go. So yeah, make sure that it stays. All right, so if it gains, add to the number above. If it loses electrons, subtract from the number above, okay? From your total electrons in your neutral atom, add or subtract. Okay, so now what it's going to ask you to do is to calculate the charge of a stable ion of your element. Remember, an ion means that you're calculating charge. So charges only come from protons and electrons. We ignore neutrons. We ignore neutrons because neutrons are neutrally charged, so they don't affect charge at all. So what we're going to go ahead and do is enter the proton charge, which should be a positive. So for my example, I had 47 here, so I would have positive 47. And my electron charge is going to, again, be from the stable ion. So not the neutral one, but the stable one from down here. We have arrows to help you out with that. And so here, mine would be 46, but again, that 46 should be negative. The negative sign is actually already here for you, so it would be negative 46. And then if I were to plug that into my calculator, again, anytime you add a negative sign, that's identical to subtraction. So this would be the same as 47 minus 46. All right, and so my answer would be I would end up with a charge of 1. And that should make sense because I have more positive protons than negative electrons. If you have more electrons, then your answer should be negative, right? So let me go ahead and type that in here, that if you have more protons, then your answer is positive. If you have more electrons, then your answer is negative, okay? But again, a good way to remember that is that adding a negative is just subtraction. So remember that this is just subtraction. All right. Okay, so that should help you out with question number 9. Question number 10 is just a research slide. So this one, you need to look up 3 compounds from ptable.com of your element. Do not plagiarize, and then you need to explain how it's used. For your explanations, do not plagiarize. You can use that information, just rephrase it in your own words and use complete sentences. So I know when you copy paste stuff, it's very obvious, so do not copy paste, right? So do not copy paste answers from ptable, okay? So really important, and also do not use Google. Do not use Google. Okay, you should only use ptable here. All right, so let me go ahead and talk a little bit about how to use ptable here. So again, make sure you have your ptable open. The link's right here for you. And what you're going to go ahead and do is, again, you're going to go ahead and now take a look at compounds at the top. So we'll go ahead and take a look at compounds. Compounds means that it's made up of more than one type of sorry, more than one type of element here, okay? So all you need to do is go ahead and take your atom, which in this case is silver, and that's my example, and just click it and drag it inside this big box right here. All right, so the big box says drag elements inside to create compounds. So drag it in there, and what you'll see is that it has over here, it now has other elements that are highlighted that can bond with silver. So not everything can bond with silver, but what I would actually recommend doing instead is once you have your silver in here, just take a look at the different compounds on the left-hand side. So once you have silver in here, all right, before you have silver in here, it has every single compound possible from our periodic table. It's a lot. So again, drag silver or drag your element in first, and then you'll see a list based on only your element. All right, now the ones that are a little bit more common have links to them. Silver is not a compound, silver is your element, so, is my element, so I'm not going to click on silver. Same thing if you're using nitrogen, don't click on nitrogen. You need an actual compound where it's related to another, where it's bonded to another element. So I'm just going to click these ones, right? So AgBr, silver bromide, I'll click that, and you'll see that it pops up a Wikipedia page. All right, so taking a look here, you're going to take a look at what is silver bromide used for. So it says silver bromide, it has unusual sensitivity to light, and so this allows it to be used for photographic materials, et cetera, et cetera. You can see all of this information here. You don't need to include all the information, just a single sentence in your own words is fine. So you would put the chemical formula, which was AgBr, and then explain how it's used, and you would explain silver bromide is used in photography because it is sensitive to light. Again, do not copy, but notice how this is written in my own words, okay? I took that information and I just rewrote it in my own words, okay? So that's what you would do here. Again, you would then click on another one, right? So we could then take a look at silver chloride. All right, so silver chloride says this is, let's see here, when it is heated, it can change. Okay, so this one, not all of them are going to have great uses, so we can go ahead and drop down here and see some uses. Right, so taking a look here, it says that it is used for pottery glazes. It can also be used as an antidote for mercury poisoning, so that's really interesting. So look for interesting facts about it. That's the whole point of this slide, is for you to learn a little bit more about how your element is used in the real world and some interesting applications for it. All right, so I could again then include AgCl. For the compound formula, you do need to include the actual abbreviations. So make sure you include the actual abbreviations, and then in your explanation include the name. So silver chromide is used, what did I say, in pottery glazes, as well as used in to help with mercury poisoning. Okay, do not copy. All right, so very simple. Again, just looking up some infrared, sorry, this is not chromide, this is chloride. So just looking up interesting facts here. All right, so that should help you with slides number 8, 9, and 10. If you need help, make sure you are coming to office hours, and I will see you later.